15, limit as p approaches infinity, so we're still doing bobo-boti, eats tc, blah, 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 you know what I mean there. Ignore this right now, so bobo-boti eats tc, these are my two leading exponents, p squared over p squared, this is eats tc, exponents the same, divide, so this limit would just be equal to negative 3 over b. Now, if this is equal to negative 3 over b, and I know that's equal to 1/3, now it should be really easy to get b. Because I'm saying negative 3 over what gives me 1/3, you can cross multiply, so then b is equal to negative 9. And then if you're like, I don't really know what I just did, well, think about this would be 5 minus 3p squared over negative 9p squared minus 2p plus 6. If I'm looking x approaching infinity, I'm just looking at this, that would be negative 3 over negative 9, which is 1/3. Oh look, that's what I said the answer should be, so yeah, my b value of negative 9 must be correct. If f is continuous at 1, what is the value of k? So I want the limit as I approach 1 from the left equal limit as I approach 1 from the right. So this is 5 times natural log of 1 minus 6 times 1 equals 2 minus k times 1. Natural log of 1 is 0. This is negative 6, 2 minus k. I added the k over and then added the 6 over. So then k equals 2 plus 6, which is 8. Alright, here we are looking for limits using both graphs. First one, limit x approaches 6 of f of g of x. So first I'm going to look at the limit as we approach 6 of g of x. This is g of x, so I'm going to approach 6, that is at 3. So then this just becomes the limit as x approaches 3 of f of x. You see how I've kind of put this in? And then now as I approach 3 of f of x, that looks like 1.5 to me. Alright, oh, this next one. This is the limit as x approaches. So as I approach 1 from f of x, that's 0. So this is just the limit as I approach 0 of g of x. And then I'm going to separate this. This is just the limit as x approaches 1 of x. So for x, right, you just literally plug in. So that's just minus 1. And then x approaching 0 for g of x is equal to positive 1. So 1 minus 1 is 0. So here I split it up. I said this limit minus this limit. The limit as x approaches 1 of x is just 1, so minus 1. Here I said x approaching 1 of f of x, and then that gave me the limit to look for g of x. Here the limit of f of x squared, so the limit as I approach 6 of f of x is negative 1, so that negative 1 is getting squared, which is positive 1. Notice that is different than g. So see how here the limit of f of x got squared? Here it's x that's getting squared. So this is the same as the limit as x approaching. If you were to plug in 2, see how that would be x going to 4 of g of x? So if we go to 4 of g of x, your limit is equal to 1. Here, this is just 2 times the limit as x goes to 4 of g of x. And as we go to 4 of g of x, that's 1. So this is just 2 times 1, which is 2. This is a case where you're doubling the x value, not doubling the limit. So this is the same as the limit as x goes to. If you plug in 1, this would be x approaching 2 of f of x. And if we go to f of x approaching 2, oh, that limit does not exist. Alright, which of the following are true? So the limit as we approach 5 of g is equal to the function value at 5. No, because my limit doesn't exist here. And that's not equal to 1 then, so not true. My limit as I approach 5 from the left is equal to the limit as I approach 5 from the right. Nope, left limit does not equal right limit. That was 4 and this one's 1. Not true. My limit as I approach 5 from the right is equal to the function value. As I approach 5 from the right, that's equal to 1. That's also my function value. So yes, that side is true. Left and right limit are the same at 6. Yes, left and right. This is for f of x, by the way. These two are equal to each other. So these two are true. Horizontal asymptote, we're talking about the bobo-boti, blah, blah, blah. I need to know my leading exponent. X times 2x become 2x squared. X squared is just x squared. So this is the eats dc. Divide coefficients. 2 over 1 is just 2. So my y equals 2 would be my horizontal asymptote. We're continuous on this interval. Oops, that's supposed to be negative 2 to 2. That's embarrassing. The equation f of x equals 1 must have a solution if k is. So this looks like an IBT problem. It's continuous. I'm going to sketch a graph so I can get the visual part. I've got negative 2. Don't know where k is. 0 is negative 3. Negative 3. And then positive 2 is down at negative 6. Somewhere like this. I want to know what value does this need to be in order to have the solution f of x equals 1. So this means y equals 1. Y value is 1 everywhere right here. So right now, just having these 2 points does not guarantee me y equaling 1 on the interval. What I need to know is the value that k must be. So I could have k, the y value that goes at negative 2, be negative 1. If I have negative 1 right here, these 3 dots do not guarantee me y equals 1. So not this. If I put k 0, again, these 3 dots do not guarantee me y equals 1. So not helpful. I could be at positive 1/2. Getting close, but I am not guaranteed at 1, so that's not going to be helpful. If I have it at positive 2, see how you would be guaranteed to cross this line at some point between these two, negative 2 and 0. So then 2 would help. And again, if I was down at negative 5, not guaranteeing me y equals 1. So 2 was the value that k had to be in order to have a solution of y equals 1. Here, making it continuous at 1, what's the value of k? So limit as x approaches 1 from the left has to equal the limit as x approaches 1 from the right. Left limit 1 squared plus k times 1 plus 2 equals 2 times 1 cosine of pi times 1. So this is just cosine of pi. Cosine of pi is negative 1. 2 times 1 times negative 1 is negative 2. 1 squared plus 2 is 3, so k plus 3. Subtract the 3 over, k is equal to negative 5. Which of the following does the limit as x approaches infinity go to 0? This is talking about the Bodhi, blah, blah, blah. Here, so if you're looking, oh, this is bigger on bottom, yes, if we're looking at the polynomials, but we talked about in class that exponentials, so e to the x is going to be greater than x to the 5 when we're talking about x going to infinity. Exponential will overpower the polynomial part. So this is my highest power actually, not the x to the 5. So as x approaches infinity, that would be plus infinity, so this would go to infinity. So not going to 0. Here, so these two would be my highest power, e to the x and e to the x. That's an eats dc. So that would be coefficients, which is 2/3. Again, not going to 0. That's bigger on top, infinity, not going to 0. Here, 2 to the x, my exponential is greater than this. So see how this is bigger on bottom? That must be equal to 0. So that's the one that has a horizontal asymptote of going to 0, or the limit as x approaches infinity is 0. Which of the following statements about f is true? The limit as I approach a, which is equal to 2, is equal to the limit as we approach b. The limit as we approach b is different from the left and the right, so this one does not exist, so it can't be true. Limit approaching a is 2, we just said that. Limit approaching b is 2, no, it does not exist, does not exist. And a, yes, that limit definitely does exist, so b is the only true one. And the horizontal line y equals 2 is an asymptote for x greater than 0. So this means that as x goes to positive infinity, the y value is going to positive 2. I don't know if it's going like this, if it's going like this, but it's definitely approaching positive 2. That does not tell me that this is the y value at 0. Definitely not. It does not tell me that y can never be equal to 2, because you could have a graph something like this, right? And you could have passed 2 even though the infinity doesn't go to 2. F of 2 is undefined. So just having a horizontal asymptote does not mean you cannot plug x of 2 into your equation. Like you definitely can have 2 in your x equals 2 in your function. As I approach infinity, the function goes to 2. Yep, that sounds a lot like what a horizontal asymptote is. And as I approach 2, it goes to infinity. That would be if I had a vertical asymptote right there. But this is a horizontal asymptote. So, whiteboard practice and answer key are up as well.